The operations presented in this video are meant to be instructional to ensure quality construction. This video is not intended to provide a comprehensive overview of safety procedures. All parties should ensure that they are familiar with and follow all safety requirements, policies, and procedures that apply to their specific operation. Surface preparation is a critical component of any asphalt paving project. Proper surface prep lays the foundation for a successful overlay, while mistakes in surface prep can lead to reduced pavement life and increased maintenance costs. Follow these steps to condition the existing surface prior to delivering the mix to the project site. Remove and dispose of loose and foreign material. Remove and dispose of excess joint sealer and crack filler. Correct irregularities in the binder course or surface being paved over. Paint existing vertical surfaces with a uniform coating of asphalt material. Apply a proper tack coat. The first step is to remove any loose and foreign materials from the roadway. The objective is to have as little foreign material on the road surface to be paved as possible. Power brooming is the most common way to achieve this. Milled surfaces present the most difficult surfaces to clean. While a first pass with a power broom will remove most of the material, as seen here, it may be necessary to wait until the moisture from the milling operation has left the pavement. Multiple passes may be required. Remember to keep workers protected from any dust generated by roadway cleaning operations. Milled surfaces need to be as clean as possible to avoid issues with tack coat picking up on the tires of delivery trucks and paving equipment. The longer a milled surface has been exposed to traffic and weather, the easier it is to get a clean surface. The use of non-tracking tack can also help reduce the amount of pickup on equipment and tires when tacking a milled surface. Loose and foreign materials may accumulate after power brooming is complete. In the fall, make sure the extra effort is made to address leaves which may blow or fall onto the roadway. Imagine the potential issues at the longitudinal joint if these leaves were not removed before paving. Other objects to remove could include tracked mud, construction debris, etc. The objective is to leave nothing in place to interfere with the bond between the overlay to the existing surface. Strive for a clean roadway. Vertical edges can often become an area where loose material and debris can accumulate, especially in excavated or milled areas where the power broom may not easily remove it. Make sure to check any vertical edges to ensure that the area is clear of loose material at the base. If necessary, use hand tools to ensure a clean surface. Paint existing vertical surfaces with a thin, uniform coating of asphalt material. This can be accomplished with either emulsions or liquid PG binder. Existing vertical surfaces include curbs, structures, gutters, and pavements. Once the surface has been properly cleaned and prepared, and all vertical edges addressed, the pavement surface is now ready for the application of a tack coat. The purpose of the tack coat is to create a strong bond between the existing pavement layer and the new overlay pavement layer to be placed. By bonding the pavement layers together, this allows the pavement to function as one deeper, laminated section, rather than many independent, thinner sections. The concept is very similar to laminating a sheet of plywood, which makes the sheets stronger together than the sum of the individual parts. Before we get into proper tack application, let's talk about what can happen if bonding is compromised. These photos all show distresses related to the lack of bond between pavement layers. While a good bond is important in all locations of the roadway, oftentimes the first places performance issues will show up is where traffic is braking, such as mountains or hills, and approaches to curves or intersections. The force of braking causes a shear stress within the pavement that overcomes whatever small amount of bond strength is present. In a properly tacked pavement, these risks should be minimized by the strong bond achieved between layers. Lack of bond takes on different looks, but usually will identify as cracking, tearing, and most notably, longitudinal movement of the material. Sometimes this failure mechanism is incorrectly identified as rutting and blamed on high asphalt content in the mix or soft base conditions. Not getting the surface preparation and tack coat right today can create a very high future cost with excess maintenance expenditures and impacts to the traveling public. Now that we have discussed the importance of tack coat on performance, let's take a look at the proper way to apply a tack coat in order to get a satisfactory result. Tack coat should only be applied on clean, dry surfaces with temperatures of 40 degrees Fahrenheit and rising. It is important to remember that once a roadway is tacked, it cannot be open to traffic until the subsequent paving course is placed, so tack coat application should be planned accordingly. Let's cover the amount of tack required by specification, which is shown in this table with a list of residual asphalt ranges specified. To understand the numbers in this table, you first need to know that freshly applied tack coat emulsion is a combination of asphalt and water. The residual asphalt means the amount of asphalt that is left on the pavement surface after the water in the emulsion has evaporated. The uniform asphalt residual range of new asphalt pavement surfaces is 0.03 to 0.05 gallons per square yard. The uniform asphalt residual range for existing asphalt pavement and Portland cement concrete surfaces is 0.04 to 0.07 gallons per square yard, and the range for milled surfaces is 0.04 to 0.08 gallons per square yard. To calculate the application rate, the inputs needed are the desired residual asphalt in gallons per square yard and the percentage of asphalt content in the emulsion, which comes from the bill of lading. The application rate can be calculated by dividing the desired residual asphalt by the percent asphalt content. For example, if an emulsion's bill of lading states that it is 62% asphalt, or 0.62, then to achieve a 0.05 gallons per square yard residual, the application rate needs to be 0.05 divided by 0.62, or 0.08 gallons per square yard. For each paving course, place a minimum 100 linear feet test strip to check the adequacy of the tack coat. It may be necessary to go further to allow the distributor to get up to speed. Check to make sure specified residual rates are being met and that the coverage looks uniform. Make corrections as necessary and reapply if the first test strip does not yield satisfactory results. Make sure it is right before continuing tack coat for the rest of the course placement. Not only is it important to get the right amount of residual tack on the surface, but also to make sure that the tack application provides uniform coverage of the entire surface to be paved. This photo shows an ideal tack coat application. In the next few photos, you will see some examples of non-uniform coverage. In these photos, there is clearly some streaking in the tack coat. Some portions of the pavement directly under the spray nozzles are covered, while other areas in between receive no tack. Make sure the proper nozzles have been installed and are properly rotated. This sheet shows different nozzles for different uses. The first nozzle is the recommended nozzle for tack coat, which at the proper pressure will create a fan that spreads the emulsion out over the surface. Satisfactory results can also sometimes be achieved using the second nozzle, one size larger. The higher numbered nozzles are designed for use in other applications such as seal coats, where much more volume of emulsion is being applied. Note the recommended application rates for the other nozzles. One of the best ways to achieve uniform coverage is to adjust the spray bar height to allow for triple lap coverage. This means that each area of the pavement should receive tack coat spray from 3 different nozzles. Individual nozzles should be rotated to spray a fan of emulsion at the manufacturer's recommended degree of rotation from the spray bar, usually 30 degrees. The objective is to keep the spray fans from hitting each other and causing streaking. Some limited interference between sprays during the application is often unavoidable. While methods to achieve sufficient tack coat coverage may vary, the end result should ensure the entire area is uniformly covered. One area of the tack application that is often overlooked is the edge of the pavement. Specifications require the tack coat to extend at least 6 inches beyond the longitudinal joint of the pavement to be placed. Note the full thick tack coat beyond the scratched course. This ensures adequate bond out to the edge of the pavement. Nice work. Note the presence of the tack coat beyond the edge of the wearing course being paved. This ensures adequate bond out to the edge. Nice work again. In this case, there is no tack at all visible under the joint or extending beyond it. This may lead to issues with poor bond at the joint area, which is the most susceptible portion of the pavement to performance issues. Distributors should be calibrated according to PTM 747. Check over the distributor and associated paperwork. Ensure material is at the proper temperature. Make sure the amount of tack being applied meets the specified requirements for the surface. Visually check the finished surface for uniform coverage. If the surface for existing pavement still shows considerable resemblance to what it looked like before the application, there likely was not enough tack applied, and the distributor calibration should be checked to ensure accuracy. In this example, the tack coverage is non-uniform and streaked. It likely does not have enough residual asphalt to meet the required range. Large portions of the existing pavement have no tack applied. The longitudinal joint is at the white edge line, so the required minimum 6-inch overlap at the joint has not been met. These issues make this tack coat unacceptable. We are looking for uniform coverage for the full paving width plus the 6-inch minimum at any joints. This application appears to be uniform and should allow for even bond across the subsequent pavement overlay. Allow the tack coat to cure before paving over it. When applied, the emulsion will come out of the distributor a brown color. When it starts to break, meaning the water evaporates out, leaving just the asphalt remaining on the surface, the color will turn from brown to black. Allow sufficient time for the material to cure. Non-tracking tack will cure more quickly. Once the tack coat has cured, the area is ready to pave. Ensure surface is as clean as possible. Determine tack application rate. Spray test strip for each course. Look for uniform coverage. Verify actual application rate. Following these steps should maximize the bond of the pavement layers and provide optimal performance.